Doesn't sound like a lot, but the fact that a dam did this is incredibly impressive. If that weren't crazy enough, it also made the Earth very slightly more round in the middle than it is at the poles.
China is drilling a tunnel through one of Earth's tallest mountains. The project, which costs $137 billion, could power 30 million upon completion, but it sits in the most earthquake-prone zone on the planet. Why build something this dangerous? What happens when mountains refuse to cooperate? Join us as we explore the mega dam that could reshape our world forever, drilling into the impossible. Deep in the mountains of Tibet, China is attempting something that sounds like science fiction. They are drilling through one of the tallest mountains on Earth, carving out a tunnel so massive it could swallow entire subway trains. This is not a small project. The tunnel will stretch 40 to 50 kilometers through solid rock, winding through a mountain range that has defeated engineers for generations. Inside this tunnel, water will rush at incredible speeds, 2,000 cubic meters every single second, a volume almost impossible to imagine. It's like an Olympic swimming pool emptying in just over a second. The goal is electricity, enough to light up 30 million homes. That is more power than entire countries use in a year. But this is not just about numbers or breaking records. This tunnel sits in one of the most dangerous places on Earth, a zone where earthquakes can strike without warning, where mountains are still growing, pushing upward as tectonic plates collide beneath the surface. Construction officially started in July of 2025. Crews began boring into rock that has stood for millions of years, rock that moves and shifts with the planet's restless forces. The question is not just whether they can build it. The question is whether they should, whether the rewards justify the enormous risks involved, and what happens if something goes catastrophically wrong in a place this remote, this unstable, this utterly unforgiving terrain. The plateau that powers a continent. To understand why China chose this specific spot, you need to understand the landscape. The Tibetan Plateau is not like other places on Earth. People call it the third pole because it holds more ice than anywhere except the Arctic and Antarctic. This plateau is enormous, 5 times bigger than the entire country of France, and it sits at an average height of 4,500 meters above sea level. Up here, the air is thin, the weather is brutal, and most people cannot survive for long without oxygen support. This plateau is special for another reason. It is the birthplace of Asia's greatest rivers. Water that falls as snow and rain here eventually flows down to feed billions of people across the continent. One of these rivers is called the Yarlung Tsangpo, and it behaves normally for about 1,000 kilometers, winding through valleys and plains like any other river. Then something extraordinary happens. The river reaches a mountain called Namcha Barwa, a peak that rises nearly 8,000 meters into the sky. Instead of flowing around this giant obstacle, the river carved a path directly through it over millions of years. This creates what geologists call the Great Bend, one of the most extreme geographical features anywhere on the planet. Here is where the magic happens. In just 50 kilometers, the river drops 2,000 meters in elevation. It's like standing at the top of a skyscraper 5 times taller than the Empire State Building, then watching water fall all the way to the ground. That drop happens over a distance shorter than a marathon race. The gorge carved by this falling water is one of the deepest on Earth, with walls of rock rising vertically on both sides. This region is so remote and unexplored that scientists are still discovering new species here. In 2024, researchers found plants and animals never seen before, living in pockets of this gorge that humans had never reached. The biodiversity here is extraordinary, a living laboratory of evolution isolated from the rest of the world. But for engineers, the biology is less important than the physics. When water falls this far this fast, it contains enormous potential energy. Every cubic meter of water dropping 2,000 meters can generate incredible amounts of electricity. This is not just good potential, it is the greatest untapped hydroelectric potential anywhere on the planet. Rivers in other countries have similar features, but none combine the extreme elevation drop with such massive water volume. The Yarlung Tsangpo carries huge amounts of water from the glaciers and rainfall of the Tibetan Plateau. When you multiply that volume by the incredible vertical drop, you get numbers that make engineers dream impossible dreams. For decades, this potential went unused because the location was simply too difficult to reach, too dangerous to build in, too politically sensitive to develop. The mountains were too tall, the earthquakes too frequent, the engineering challenges too severe. But technology changes, ambitions grow, and eventually someone decides that impossible just means difficult. China looked at this bend in the river and saw something worth $137 billion, worth the risk, worth attempting what others called unbuildable. Why China needs this mountain of power. China has an energy problem that most people do not fully understand. The country consumes twice as much electricity as the United States, which is already one of the world's largest energy users. Compared to Russia, China uses 8 times more power. Every single day, factories hum, cities glow with lights, trains speed along electrified tracks, and the demand for electricity keeps climbing. This hunger for energy is not slowing down, it is accelerating. For generations, China burned coal to meet this demand. Coal is cheap, abundant, and China has massive reserves buried underground. But coal creates a different problem. When you burn it, you release carbon dioxide into the atmosphere, contributing to climate change. China became the world's largest emitter of greenhouse gases, and the smog in cities like Beijing became so thick that people could barely see across the street on bad days. Then China made a promise. By 2060, the country committed to reaching net zero emissions. That means balancing out every ton of carbon release with carbon removed or prevented. This is an enormous challenge for a country this size, with this much industrial activity. Meeting that goal requires completely transforming how China generates electricity. The country has already started building renewable energy at a scale never seen before. Solar farms stretch across deserts, covering areas larger than entire cities. Wind turbines spin along coastlines and mountaintops. Engineers are even experimenting with tidal power, capturing energy from ocean waves. China now installs more renewable energy capacity every year than most countries have in total. But solar and wind have a fundamental weakness. The sun does not always shine, the wind does not always blow. At night, solar panels sit useless. On calm days, wind turbines stand still. Modern society needs electricity 24 hours a day, 7 days a week, without interruption. Hospitals cannot close when the wind stops. Factories cannot shut down when clouds cover the sun. This is where hydropower becomes critical. Water stored behind a dam can generate electricity whenever you need it. Turn a valve, let water flow through turbines, and power flows into the grid instantly. Hydropower provides reliable, controllable, 24/7 electricity without burning anything. China has already built over 87,000 dams, more than any other nation. The most famous is the Three Gorges Dam, currently the most powerful hydroelectric facility on Earth. Three Gorges can power 34 million homes, an achievement that seemed impossible when construction began. But even Three Gorges is not enough. China needs more clean, reliable power to replace coal plants and meet growing demand. The Yarlung Changpo project offers something extraordinary. If completed, this system could generate 3 times more power than Three Gorges, 3 times more clean electricity flowing into the grid, reducing dependence on coal, helping China inch closer to that 2060 deadline. The math is simple but staggering. More people need more power. Coal cannot be the answer anymore. Solar and wind help, but cannot provide constant power. Hydropower can, but only if you find the right location. China found that location in the most difficult place imaginable and decided the reward justified any risk. Engineering, the unthinkable. Traditional dams work by building a massive wall across a river, creating an enormous lake behind it. The weight of all the water pushes through turbines at the bottom, generating electricity. But this project uses a completely different approach called a run-of-river system. Instead of blocking the water and flooding valleys, engineers plan to drill directly through the mountain itself. The concept sounds simple, but the execution is anything but. Water enters the tunnel system at high elevation on one side of the mountain, then flows downward through the rock, exiting at much lower elevation on the other side. As gravity pulls the water down through the tunnels, it passes through 9 separate hydroelectric stations, each one capturing energy from the falling water. The system includes 5 cascade power stations working in sequence, connected by 4 major tunnels. Each tunnel stretches roughly 20 kilometers through solid rock. This is equivalent to drilling a hole the length of 200 football fields placed end to end, except you are drilling through granite and limestone instead of air. The tunnel must handle peak flows of 2,000 cubic meters per second, a torrent of water moving with devastating force. If everything works as planned, the system will generate 300 terawatt hours of electricity every single year. That is enough to power entire regions, replacing dozens of coal-burning power plants. Engineers argue this approach is more environmentally friendly than traditional dams, because you do not flood massive areas, destroying ecosystems and forcing people from their homes. The tunnel length is comparable to the Channel Tunnel connecting England and France, except that tunnel was built through relatively stable rock under the ocean floor. This tunnel cuts through a mountain range that literally moves and shakes, where the ground beneath your feet can shift without warning. The engineering challenge is immense. Boring machines must cut through different types of rock, some hard as steel, some fractured and unstable. Water seepage could flood work areas. Rock falls could crush equipment and workers. Temperature and pressure deep inside the mountain create conditions that destroy normal construction tools. This is not just difficult engineering, this pushes the absolute limits of what humans know how to build, where earthquakes rewrite the landscape. The Himalayas sit on top of a geological war zone. Two massive pieces of Earth's crust, the Indian plate and the Eurasian plate, are slowly colliding. This collision has been happening for 50 million years, and it is not finished yet. The force of India pushing northward into Asia creates the Tibetan Plateau and keeps pushing the Himalayas higher. Every year, these mountains rise about 5 centimeters, growing taller as you read these words. This ongoing collision makes the region extremely unstable. Earthquakes are not rare events here, they are expected. Inevitable parts of living on top of grinding tectonic plates. The question is never if an earthquake will strike, only when and how powerful it will be. In 1950, a massive earthquake measuring 8.6 on the Richter scale struck near the Yarlung Tsangpo River. The shaking was so violent that entire mountainsides collapsed into the river, blocking the water completely. For 8 days, the river could not flow. Water backed up behind this natural dam made of millions of tons of rock and soil. Then, the makeshift dam failed. 8 days of accumulated water burst through in a catastrophic flood. A wave 7 meters tall roared down the valley, destroying everything in its path. Over 500 people were swept away by water or buried under debris. Villages vanished completely. The flood reached far downstream, affecting communities that had no idea what had happened in the mountains above them. Landslides continue to threaten the region. As recently as 2021, major landslides temporarily blocked parts of the river. Climate change may be making this worse. Melting glaciers and destabilizing slopes that have been frozen for thousands of years. The tunnel project sits directly in this active earthquake zone. Engineers can build structures to withstand shaking, they can reinforce rock and install monitoring systems. But nobody can stop the Earth from moving. The real concern is not if an earthquake happens during construction or after completion, it is what happens when it does. A major earthquake could crack the tunnel, causing catastrophic flooding. Water under immense pressure could blast through fractures, turning the tunnel into a weapon aimed at everything downstream. A river that crosses borders. The Yarlung Tsangpo does not stay in China. After carving through the Himalayas, the river crosses international borders and becomes the lifeblood of 2 other nations. In India, people call it the Brahmaputra River. Further downstream in Bangladesh, it becomes the Jamuna River. 3 countries, 3 names, 1 river connecting hundreds of millions of people who depend on its water. In India's Assam region, farmers rely on the Brahmaputra for irrigation. Rice paddies need consistent water flow during growing seasons. Too little water means crops fail and families go hungry. In Bangladesh, the situation is even more critical. The river carries sediment, tiny particles of rock and soil eroded from the Himalayas. When floods spread the sediment across the land, it creates some of the most fertile farmland on Earth. Generations of Bangladeshi farmers depend on this annual renewal of nutrients. Any change to the river's natural flow creates serious problems. If China's dam system traps sediment behind turbines, less reaches Bangladesh. Without sediment, the land loses fertility. If China controls water release, downstream regions could face unexpected droughts when they need water most, or devastating floods when excess water gets released all at once. Currently, there is no comprehensive water sharing agreement between these 3 nations. Nobody has legal authority to decide how much water each country deserves. This creates tension, especially between India and China. In 2020, soldiers from both countries clashed along their disputed border. 20 Indian soldiers passed away in hand-to-hand combat. Trust between the nations remains fragile. India's response to China's dam project was to announce its own plan, a 10-gigawatt dam on the same river system. This sparked what some analysts call a dam race, each country trying to capture water resources before their neighbor does. Water is becoming as strategic as oil, a resource worth fighting over. The problem is that rivers do not respect political boundaries. What happens in Tibet affects farmers in Assam and Bangladesh. A decision made in Beijing can mean drought or flood for millions of people who have no voice in that decision, conquering the world's harshest terrain. For most of human history, the location of this dam project was essentially unreachable. Mountains rose so steeply that building roads seemed impossible. The few paths that existed were little more than trails carved by locals who knew every dangerous turn. Supplies had to be carried by hand or on the backs of animals. Heavy construction equipment could not get anywhere near the site. Everything changed in 2013 when China completed the first year-round road into the region. Even this road is not easy to travel. It winds through mountain passes where landslides happen regularly. During winter, snow and ice make sections impassable, but at least large trucks can now reach the construction zone, carrying the massive boring machines and tons of concrete needed for the project. Workers face conditions that would send most people home immediately. The altitude alone creates serious health problems. At 4,000 meters and higher, there is significantly less oxygen in every breath. People get headaches, feel dizzy, and tire quickly from simple tasks. Construction workers must acclimatize slowly, or risk altitude sickness severe enough to endanger life. The weather adds another layer of difficulty. Temperatures can drop far below freezing even during summer nights. Winter brings blizzards that halt all outdoor work. The short construction season means every day of good weather must be used efficiently. Then there are the constant geological threats. Landslides can bury equipment and workers without warning. The ground itself is unstable, shifting as tectonic forces continue pushing the mountains higher. Engineers must constantly monitor for signs of slope failure or underground water that could flood tunnels. Current cost estimates range from $130 billion to $170 billion. This makes it one of the most expensive construction projects in human history. The timeline for completion targets the early to mid-2030s, meaning construction will take roughly a decade if everything goes perfectly. If China succeeds, they will have built the most powerful hydroelectric system ever created. It would represent a major leap toward the 2060 carbon neutrality goal, but success is far from guaranteed. Every day of construction brings new risks, new challenges that no engineering textbook fully prepared anyone to solve. Risk, power, and global consequences. Not everyone believes this project is a good idea. The debate splits people into camps with very different priorities, and finding middle ground seems almost impossible. Environmental scientists worry about what will happen to one of Earth's last unexplored ecosystems. The Gorge region contains species found nowhere else on the planet. Some of these plants and animals were only discovered in the last few years. Scientists have barely begun studying this unique environment. Building massive tunnels and power stations could destroy habitats before we even know what lives there. Once extinct, these species can never be recovered. The project will also change how the river behaves. Natural flooding patterns evolved over millions of years. Fish, plants, and entire ecosystems adapted to seasonal changes in water flow. Controlling the water for power generation means these natural rhythms disappear. Downstream ecosystems that depend on regular flooding could collapse completely. Geologists focus on different concerns. They point to the seismic data showing this region experiences major earthquakes regularly throughout history. Building critical infrastructure in an active earthquake zone seems reckless. Even if the tunnels survive moderate shaking, a truly massive earthquake could cause catastrophic failure. The consequences would not stay local. A tunnel breach could send devastating floods racing downstream toward populated areas. Political analysts see the project as a dangerous escalation of regional tensions. India and Bangladesh already feel vulnerable to Chinese control over their water supply. This dam gives China enormous leverage. During disputes, China could theoretically reduce water flow, creating droughts downstream. Or they could release excess water suddenly, causing floods. Whether China would actually do this matters less than the fact that they could. Supporters argue the world needs clean energy desperately. Climate change threatens everyone. If this project can replace coal power plants and reduce carbon emissions, the benefits could outweigh the risks. They point out that doing nothing also has consequences. Continuing to burn coal guarantees environmental destruction. At least hydropower offers a path forward. The central question comes down to acceptable risk. How much are we willing to gamble for clean energy? Can engineering overcome nature's dangers? Should one country control resources that affect millions of people across borders? There are no easy answers, only difficult choices with uncertain outcomes. Closing reflection. Somewhere in the Himalayas. Right now, drilling machines are boring through solid rock. Workers in hard hats operate equipment in thin air and brutal cold. Engineers review plans and calculations, trying to account for every possible failure mode. The tunnel grows longer each day, meter by meter, advancing through a mountain that has stood for millions of years. This is a 50-kilometer tunnel carved through some of the most unstable geology on Earth. The goal is to capture one of the planet's most extreme drops in elevation and turn falling water into electricity for 30 million homes. The scale is difficult to comprehend. The ambition seems almost arrogant, humans challenging nature at its most powerful. For China, this project represents more than just electricity generation. It is a statement about technological capability and national power. It announces to the world that Chinese engineering can accomplish what others consider impossible. It demonstrates commitment to carbon reduction even when that commitment requires extraordinary effort and expense. But symbols and statements do not change physics. The earthquakes will continue. The tectonic plates will keep grinding against each other. The mountains will continue rising and occasionally collapsing. Nature does not care about human ambition or engineering confidence. Perhaps this is the future of clean energy, massive infrastructure projects that harness natural forces on unprecedented scales. Perhaps this shows humanity's ability to solve the climate crisis through bold action and technological innovation. We learn to work with nature's power rather than against it. Or perhaps we are pushing too far, building in places we should leave alone, taking risks we do not fully understand. Perhaps some locations are dangerous specifically because they are powerful, and trying to control that power will eventually lead to disaster. The final question remains unanswered because the project is not finished. Years from now, we will know whether the tunnel holds or fails, whether the earthquakes stay manageable or turn catastrophic, whether downstream nations find ways to cooperate or remain locked in conflict over water. Until then, the drills keep spinning, the tunnel keeps growing, and the mountain waits.